Scholarity Solutions is a balanced staffing company developed by a group of professionals with an experience of over 18+ years in staffing solutions. With years of quality and committed high-end application development and staffing experience, we have become experts at delivering the right fit, the first time. We will be glad to be your last stop and provide you with the perfect solution to your requirements. Follow Scholarity Solutions LinkedIn page. For more updates, follow our social media pages.
Hello all, I'm Harika from Scholarity. This is a webinar wherein we will discuss regarding functions in Python. This online webinar is organized by Scholarity Solutions. Scholarity is IT solutions provider. Scholarity is a group of professionals with technical and domain expertise and now an experienced and robust team of efficient people serving its clients in entire USA. It is one of the best company in US. You can follow Scholarity social network like website, Facebook, and LinkedIn page. This is the first point. That I'm going. Then you will get a chance to call it. What my point? First, you have to define the function. Then only you will get a chance to call it. Okay. So before calling, before defining, you should not call. First, you define. Then you will get a chance to call it. So these 2 points you have to remember before discussing this program. So let us understand how this program is going to work. So these are not executed because I haven't called them yet. So they will not be executed. This will be the first line in the result. Calculating the addition will be the first line in the result. See, you are calling the sum function. Instead of writing the reusable code, what you are doing, you are putting the name of the block in which the reusable code is available. So you are calling the sum function. Then the cursor will go to the sum definition, executes the definition properly and completely. So A is 10, B is 20, 10 plus 20. Print C means what? 30 is printed. After executing the function, the cursor will execute the next instruction which is written after the call. Of course, as per the sequence, this line only should get executed, right? This is already over. So when the call is encountered, the cursor will go to the definition with that name, executes the definition. After that, it will go to the next instruction which is written after the call. As per the sequence, of course, this line only. So it will print 30 and then it will come here. Calculated the addition successfully will be the result. Okay, fine. Now calculating the subtraction will be printed. You are calling which function? The sub function. Now the cursor will go to the sub definition. 10 minus 20 minus 10 is printed. After executing the function, the cursor will go to the next instruction which is written after the call as per the sequence. So calculated the subtraction again successfully will be printed. Now calculating the multiplication will be printed. We are calling the mul function. The cursor will go to the mul definition. 10 into 20, 200 is printed. So after executing the function, the cursor will go to the next instruction which is written after the call. So calculated the multiplication successfully will be printed. Calculating the division is printed. You are calling the div function. The cursor will go to the div definition. So 0.5 is printed. After executing this function, the cursor will go to the next instruction written after the call. So calculated the division successfully will be printed. Now calculating the addition again will be printed. So you are calling the sum function for one more time. Can't we do that? Can't we call for one more time? Definitely yes. For any number of times we can call. That is what the advantage. So again the cursor will go to the sum function. 10 plus 20, 30 is printed. After executing that, it will go to the next instruction written after the call. So calculated the addition again successfully will be printed. After this, there is no more instruction written, so the program execution is terminated or stopped. So what is the principle that we have to remember here? When call is encountered, it will go to the definition, executes the definition, and goes back to the next instruction which is written after the call. Okay, it is simple, right? So let me execute this program. So I am using PyCharm, which is very famous editor to write and execute the Python code. So I am in functions2 project and in 1.py file. So right click, run one. My file name is 1.py. I am running this. Right click, run one. So see, the expected result came for us. Calculating the addition, 30 is from the definition. Calculating the addition and calculated the addition successfully has got printed. Calculating the subtraction, minus 10 from the definition. Calculated the subtraction successfully has got printed. Calculating the multiplication, this 200 value from the function definition, mul definition. So calculated the multiplication successfully has got printed. Calculating the division, 0.5 from the div function. Calculated the division successfully has got printed. Calculating the addition again, 30 from the sum definition. This is the result from sum function. Calculated the addition again successfully is the next value. Next result in the output. So fine. Finally, what I'm saying is we will use the functions to achieve code reusability. Instead of I write the same code again and again, I will put my code in a block and I can give some link to the block. So wherever I want, I can call that function. That means I can execute the reusable block again and again. So we will see one more example for getting more clarity on this. So this is our program. Actually, what will happen means, so please don't think that hello, good morning to all is the first line in the output. No, I already told that if I write the function, that will not be executed. If I call, then only it will be executed. So what is the first line in the output? Hi. Hi is the first line in the output. See which function you are calling now? Hello. So the cursor will go to the hello definition. It will print this. Hello, good morning to you all will be printed. After executing the definition, the cursor will go to the next instruction which is written after the call. So we are calling the party function. Again, the next line is also a call. That's okay, no problem. The cursor will go to the party definition. It will print welcome to get together party or whatever the logic you write there, that will be executed. Again, after executing the function, it will go to the next instruction written after the call. So it's nothing but by, you're making a call to the by function. The cursor will go to the by definition. By have a lovely day will be printed. So after executing this, it will go to the next instruction written after the call. So done is also printed. Okay, just a second. I'm turning on the charger switch. Yes. So hope you understand the concept. At least you got some basic idea on this. See, in the previous program, we had written 4 functions, right? Like sum, sub, mul, div, like that. See, there is some problem in the sum function, if you can observe. So what is the problem? If I call the sum function for the first time, it can add 10 and 20 only. If I call the sum function for second time, then also it can add 10 and 20. If I call the sum function for third time, then also it can add only 10 and 20. That means this definition is capable of adding only 10 and 20. Why like that? Because you have fixed the values like that. You have fixed the values like that now. So for how many times you call this function, for those many times it can add only 10 and 20. Fixing of values is called as hard coding. Fixing of values is called as hard coding. See, I want my definition to be very, very flexible. Sorry, I want my definition to be very, very flexible. It's not like my function should be able to add only 10 and 20. I want my function to add any values that I require. So how can I do that? How can I make my function to be flexible? Let us understand. So let us consider this. See, I am calling the sum function. Now what will happen? The cursor will alone go to the function. If I call the sum function, then what will happen? The cursor will alone go to the sum definition. Correct? Now what I am doing? I am calling the sum function with 2 and 3. I am calling the function with sum function with 2 and 3. Now what will happen? The cursor along with 2 and 3 will go to the definition. The cursor along with 2, 3 will go to the function. To hold 2, I am taking an entity A. To hold 3, I am taking an entity B. Let us say I am calling the function like this. 2, 3, 4. Now the cursor along with 2, 3, 4 will go to the definition. So to hold 2, I'm taking an entity A. To hold 3, I'm taking an entity B. Then to hold 4, I have to take an entity, right? So I'm taking C. See what exactly going to happen here. 2 will automatically be copied into A. 3 will be copied into B. 4 will be copied into C. Okay, so this is what that is going to happen. So what I will do now, I will call the sum function with 2 and 3. To hold this 2 and 3, we are taking two entities, namely A and B. 2 will be copied into A and 3 will be copied into B. 3 will be copied into B. Fine. So we will put this aside. We will consider this piece of code. See, we are calling the sum function with 2, 3. Now, the cursor will go to the sum definition. The cursor will go to the sum definition with 2 and 3. We know that 2 will be copied into A and 3 will be copied into B. So, 2 plus 3, 5. So, print C means what? 5 will be printed. After executing the function, the cursor will go to the next instruction which is written after the call. This is the call, right? Now the cursor will go here. But the next line is also a call. No problem. Now I am calling the sum function with 10 and 20. 10 will be copied into A, 20 will be copied into B. So 10 plus 20 is what? 30, and 30 is printed. After executing the function, the cursor will go to the instruction which is written after the call. That means the cursor will come here. But this instruction is also a call. No problem. Again it will be called. Now the sum function is called with 100 and 200. 100 will be stored into A. 200 will be stored into B. 100 plus 200 is 300. So 300 will be printed. See, now my definition became very, very flexible. So earlier what happened? Earlier I had given like this. I don't take anything here. So whatever the values you put inside the block, the operation will be performed on those values only. But now I made my definition to be flexible. Whatever you pass, whatever you give to AB, the operation will be performed on those values, or the addition will be performed on those values. Correct? So now my function really became flexible. So hope you know the way to take the inputs from the user in Python. So using input function, I am accepting the input from the user. So I am accepting the first number into X variable, and I'm accepting the second number into the Y variable. So let us say the X value is 2 and Y value is 1. So here the sum function is called with X and Y. What is XY values given? What are XY values given by the user? Let us say the X value given by the user is 2 and Y value is 1. So you are calling the sum function again with 2 and 1. So now the cursor will go to the definition. The X value given by the user, that is 2, will be copied into A. The Y value given by the user, that is 1, will be copied into B. So that means what? XY values will be copied into AB. That means 2 and 1 will be copied into AB. So 2 plus 1, 3, and 3 is printed. That means what? We can even pass the user inputs to the function. We can pass the inputs of the user to the function, and we can perform operations on those values also. So this function is really, really flexible. And see, here, this 2, 3, 10, 20, 100, 200, these are called as what? These are called as parameters. Parameters. What is a parameter? The extra information sent from the call to the definition. Extra information sent from the call to the definition are called as parameters. 2, 3, 10, 20, 100, 200, x, y. This is the extra information which is passed to the function, right? So they are called as parameters. And we should never use the term called as variable for this. X, Y, A, B are the variables? No, they are not at all the variables. Then what are they? See, X, Y are the entities used in the call. X and Y are the entities used in the call. The entities used in the call are called as parameters or actual parameters. The entities used in the call are called as parameters or the actual parameters. Why X and Y are called as actual parameters? Because this is the actual data on which the operation has to be performed. Correct? On 2, 1 only the operation has to be performed, right? So this is the actual data on which the operation has to be performed. That's why it is called as, that's why they are called as actual parameters. So here the entities used in the definition. This is the function or function definition. The entities used in the function are what? A and B, correct? The entities used in the function are called as formal parameters or arguments. The entities used in the function, that is A and B in our case, are called as formal parameters or arguments. Why they are called as formal parameters? You have taken AB formally to hold the actual data, correct? To hold 2, 3, 10, 20, 100, 200, 2, 1. To hold the data, formally you are taking AB. So A and B are called as formal parameters or arguments. A and B are called as formal parameters or arguments. So what I am saying here is the entities used in the call are called as actual parameters or parameters. The entities used in the definition AB are called as formal parameters or arguments. Sometimes in the interviews, people will ask like this, where parameters will be there, where arguments will be there. Parameters will be there in the call, arguments will be there in the definition. Correct? Parameters will be in the call, function call. Arguments will be there in the function definition. Function definition. So actually the function which is seen earlier, see this is seen earlier, right? So somebody we are writing. See, this is a function. This is the first type in the function. So this is a function without parameter or argument. Functions without arguments or parameters. The second one which we have seen just now, that means we kept like this now. So this is what? Functions with arguments. Functions with arguments. So this is functions without arguments. This one I am saying. I will show again if you want. So this is the function without arguments, because I don't take any argument here like A, B and all. And this definition, or this is a function with arguments. This is a function with argument. Okay. So now what we will do, see, we will have to see an important concept called as function returning values. But before seeing that, I will tell what is returning, why to return and all. So to understand that concept, firstly, I will tell you a concept called as local and global variables. Basing on this, we can understand the functions returning and all. See, what is a local variable? What is a global variable? That is the point here. I am Harika. I am working in a company. In my company, who is Harika means everyone knows. But outside the company, who is Harika means no one knows. In my company, I am known to everyone. But outside my company, I am not known to anyone. Let us say. So I am local to my company. I am local to my company. Let us say the president of the country is there. In my company, who is president? Everyone knows. Outside the company, who is president means everyone knows. So president is like global. Harika is local to the company, but president means he's like global. Okay. Like that, see, I will create a function, or I will create a block here. So in this block, I will write like this, a equal to 10. And I will write like this, print a. So if I ask for a, I am going to get 10 because the value of a is 10, which is defined there. I will come outside the block. I will come outside the block, and if I ask for a, will it be giving 10 for me? No, I will end up with an error. Unresolved reference. Unresolved reference. A, like that the error will come. Why like that? A is there now. Why it is saying that undefined and or unresolved? See, you have created a inside the data block. You have created a inside the data block. Correct? So it is recognized only in this data block. See, you have created a inside the data block, right? It is recognized only inside this data block. Outside the data block, this is not recognized. So this a is called as what? Local variable. A is called as what? Local variable. So this is a comment in Python, right? They are not considered at the time of execution of program. This is just for our own sake, correct? So A is called as which variable? A is called as the local variable. See, variable that has got created inside a block is called as local variable. Variable that is created inside a block is called as local variable. It is available or accessible or visible only in the same block in which it is created. I have created A inside the data block. So this A is recognized only in this block. So A is Harika, data is like company. I am known only in my company. This A is recognized only in this data block. Outside the block, if you ask for A, it is not recognized. See, now I have created a variable like this, x equal to 100. See, this is a variable that has got created outside of all the blocks. Now it's like president of the country known to everyone. See, x is a variable which is created outside of all the blocks. So that is nothing but a global variable. See, global variable is recognized throughout the program. So if I write print x, then what will happen? Yes, 100 will be, yes, 100 will come. And inside the block, if I ask for x, yes, it is 100. Outside the data block, if I ask for x, yes, it is 100. So the variable that is created outside of all the blocks is called as a global variable. It is recognized throughout the code. It is recognized throughout the code. So inside the block, I can use A. Outside the block, I can use A. Inside the block, I can use X. Outside the block also, I can use X. So what is a local variable? Variable that is created inside a block is called as local variable. It is recognized only in the same block in which it is created. Variable that has got created outside of all the blocks is called as global variable. It is recognized throughout the code. Inside the block, outside the block, wherever you want, you can use it. Okay. So now let us see. I will write one code and I will show one problem in that code. Let us consider like this. I'm creating the sum function which is going to take 2 arguments and I will write like this: c equal to a plus b, print c. Now what I will do, I will call the sum function. I will call the sum function. See, now what will happen? Like what I will do now, I'll just take like this also. D equal to c plus 10, print d. So now what I am going to do here, how this code is executed. See, here is the call to the function sum. So what I'll do here, I'll simply, let us say I'm taking this directly without user involvement. So what I will do here, I will call the sum function with 2, 3. When the call is encountered, the cursor will go to the function definition. Now, the cursor will go to the sum function with the 2 and 3. So 2 plus 3 is how much? 5. 5 will be printed. Good. Okay. After executing the function, the cursor will go to the next instruction which is written after the call. Correct? As per the sequence. After executing the function, the cursor will go to the next line after the call. That is what we have discussed up to now. So what I am doing, c plus 10. What is c value? 5. 5 plus 10. 15 is expected to be in D and 15 is expected to be printed. Yes or no? You are calling the sum function with 2, 3. The cursor will go to the definition with 2 and 3. 2 will be into A, 3 will be into B. A plus B means what? 2 plus 3. So 5 is printed. Then after executing the function, the cursor will go to the next line written after the call. So 5 plus 10 is 15 and 15 will be the result. That is expected actually. But here we are going to end up with an error. Here the error will come. Isn't it? Why like that? What is the error? Unresolved reference C. I don't know what is C. Why C is 5, right? Why it is telling that it doesn't know what is C? C, actually, you want to use 5 here, right? That's why you are giving like C. But C is created in where? You have created C inside the sum block. You have created C inside the sum block. So this C is recognized. The variable C is recognized only in the sum block. So C is which variable? C is a local variable. You know, local variable means what? Variable created inside a block. And the C is available only in the same block in which it is created. Outside of the block, that C is not recognized. Correct? C is recognized only in some block. Outside the block, how can you ask for C? You cannot ask because it is not recognized. It can't be recognized. So what is the problem here? See, 5 is the result of the reusable block. 5 is the result of the reusable block. So what has happened here? You are unable to use the result of the reusable block from outside the block. See, what is the result of the reusable block? 5, right? You are unable to use that 5 from outside the block because 5 is there in which variable? Local variable. So you cannot use that C or 5 from outside the block. Again, I'm saying the problem is you are unable to use the result of the reusable block from outside the block. The result of the reusable code is 5 and you can't use it outside the block because that C is there in local variable. But somehow there should be some way to use this 5, right? I should be able to use the result of the reusable block even from outside the block. So in order to achieve that, in order to use the values of local variables from outside the block, we have a concept called as functions returning values. Functions returning value or values, whatever. So before explaining this, I will write a small piece of code for one more time. So def sum a comma b print c. I will call the sum function with 2, 3, and I will write down here. Okay, so now let us see the output. Hope you all know the output of this code. It's very simple, right? You are calling the sum function with 2, 3. The cursor will go to the definition with 2 and 3. 2 will be copied into A, 3 will be copied into B. 2 plus 3 is 5. 5 is printed. Now, we pretty well know that after executing the function, the cursor will go back to the next instruction which is written after the call. That means after printing 5, the cursor will go to printer done and done is printed. I want to make sure this point, like I want you to recollect this point. What is that? After executing the function, the cursor will go to the next line which is written after the call. After the call. Remember that word, after the call. So, okay, fine. We will put that aside. Now what I will do, I will introduce a new keyword in the function. What is that? Return keyword. Return C. See, please listen very, very carefully. We have discussed it like this. After executing the function, the cursor will go to the next instruction written after the call. But in the definition, if return keyword is there, in the definition, if return keyword is there, then after executing the definition, the cursor will go back to the calling place. Generally, what I told, so generally after executing the function, the cursor will go to the next line written after the call. But in the function or in the definition, if return instruction is there, then the cursor will not go to next line. After executing the function, the cursor will go back to the calling place in which line it has encountered the call. To the same line it will go. So here the sum function will be called with 2, 3. 2 will be into A, 3 will be into B. So 2 plus 3 is 5. So return C. C means what? 5. Now the cursor will go back to the calling place with the value 5. Okay, the cursor will go back to the calling place with the value 5. To hold this 5, you are taking a variable D. Now this 5 will be copied into which variable? Now this 5 will be copied into D variable. Now this 5 is copied into D. See, one thing you understand, earlier your 5 is there in variable, in a local variable. Now your 5, the result of the reusable block is 5, right? You have 5 in a variable which is outside the block. That means you have 5 in a global variable. So now I can use that like anything as per my requirement. Now I can use that 5 or D as per my requirement. Equal to D plus 10. Print E means what will happen? So here 15 is printed and also done. See, I will tell again. Actually, we are calling the sum function with 2, 3. So the cursor will go to the definition with 2 and 3. Here 2 will be taken, here 3 will be taken. 2 plus 3 is 5. Return. Return means what? The cursor will go back to the calling place, not to the next line. Where is the call encountered? To the same line, the cursor will go with the value 5. To store that 5, you are taking the variable D. So D plus 10, 5 plus 10 is how much? 15. So 15 is the result and also done is printed. Simply what we had done here, we had copied the value of local variable into a variable, into a global variable. Correct? We have copied the value of local variable into a global variable so that I can use that value. So if there is no return instruction in the function, the cursor will go to the next instruction written after the call. But if there is return instruction, the cursor will go back to the calling place with that value. So here the sum is called with 2, 3. 2 plus 3 is 5. Return C means what? The cursor will go back to the calling place with the value 5. To hold this 5, you are taking a variable D. So D plus 5, that is 10 plus 5, 15. Earlier you are unable to use that 5, but now you can use that 5 because it is there in a global variable. Correct? So this is the advantage of returning. Why? What is the purpose of returning of values? If we want to use the values of local variables from outside the block, then returning is going to be helpful. So we will see one more example on returning. Yes. So we will just put this example in Python once. Fine. So here what is happening? We are calling the sum function with 2 and 3. The cursor will go to the definition with 2, 3. 2 plus 3 is 5. Return means what? The cursor will go back to the calling place with the value 5. You're storing 5 in D. D plus 3, 5 plus 3 is 8. So 8 is printed and also done is printed. Okay, 8 and done will be the result. So we will see one more example for being more clear. So what is going to happen here? I'm trying to calculate the average of marks. Basing on that, I'm determining the grade of the student. So see what we are doing. We are calling the average marks function with 88, 98 and 90. Correct? So now what will happen? The cursor will go to the average marks function. You are calling which function? Average marks. See, this is a function call, right? You are calling the average marks function with 88, 98 and 90. So the cursor will go to the definition with 88, 98 and 90. So 88 will be copied into A, 98 will be copied into B, 90 will be copied into C. I'm just summing them up and calculating the average by dividing it by 3. So 88 plus 98 plus 90 by 3. So it's nothing but 92. Print X means what? 92 is printed. 92 is printed. So return X means what? 92. So what we have discussed in the definition, if return keyword is there, then after executing the definition, the cursor will go back to the calling place I told, not to the next line. So return X. X means what? 92. So with the value 92, the cursor will go back to the calling place. So here is the call, right? Here is the call for average marks function, right? So the cursor will come here with the value 92. To hold this 92, you are taking a variable n. To hold 92, you are taking a variable n. So now the local variable's value, x value 92 is available from outside the block also, because it has got copied into a local variable, global variable n. So 92 is there in n. 92 is greater than or equal to 90? Correct. So it will execute the if block. A plus grade is printed. See, hope you know the principle for if elif. Where the condition is satisfied for the first time, it will enter into that block, executes the instructions of that block, and it will skip all the remaining if elif blocks. Correct? That is the principle of if elif, right? So what happened here? We are calling the average marks function with 88, 98 and 90. So 88, 98, 90 will come here into ABC respectively. So 88 plus 98 plus 90 will be into D, and D by 3. The final value is 92. 92 is printed. Return means what? With the value 92, the cursor will go back to the calling place in our case. So to hold this 92, we are taking a variable n. So n is 92 now. 92 is greater than or equal to 90. Correct. So what will happen? A plus grade is printed and the remaining code is kept. There is no more instruction written. So the program is terminated or stopped. So is it mandatory to return a value? No. If the task is to calculate the average, then no need to return. Here is the average calculation logic. So that is over. But basing on the average value, if you want to determine the grade, if you write the grade logic outside the block, then definitely this value is required. Average value is required. So if you really want to use that value from outside the block, then you return. Otherwise, it is not required. If you really want to use this 92 from outside the block, then you return. If you don't want to use that, then no need to return. So it's not mandatory to return. Okay, that is what the concept is. So finally, I can say that we are using functions to achieve code reusability. So instead of writing the reusable code again and again, we can put our reusable code in a block and we can give some name to the block. So wherever we want to write the reusable code, there we can just put the name of the block in which it is written. So function is a reusable block which can be used for any number of times anywhere in the program. The purpose or advantage of having functions in our program is to achieve code reusability. So functions without arguments, functions with arguments, functions returning values. Even there are some other types of functions, but we have covered the very important types of functions. Okay, so thank you all for attending the webinar.